Why can't we divide by 0? Why?
I love that.
That's a great question.
I've carried that with me my whole life.
Right.
Because the answer is, well, it's undefined. And so my response is, well
then define it.
Define
Right.
Get off your duff and define it.
Yeah, exactly. Define it. And you know who does? The mathematicians, actually. There are parts of math, one in particular called projective geometry, where one of the objects in there is essentially what we want to get at by the idea of 1 divided by 0. And the thought is, if you have a number line and you walk infinitely far either to the left or to the right, there's this unified point that you're approaching called the point at infinity. And you can do useful math by defining that. And that's kind of what you're getting at when you have this notion of 1 divided by 0. But if you're not doing that and you want to say, like, why isn't it defined? I mean, it depends on what you're doing with division, right? If what you want to say with division is like, I have 1 cupcake and I'm dividing it among 3 people, how many does each of them get? And you're like, a third of a cupcake. If I have 1 cupcake and I'm dividing among 0 people, it's like, it's an incoherent question. Like, the cupcake's got to go somewhere. The fact that question is incoherent is maybe what we mean by saying that it's undefined.
See, but that's my point. In practical terms, I have 1 cupcake and I want to divide it between 0 people. We got to go back to the beginning of the statement. I have 1 cupcake. Okay?
That's the answer.
And that's the answer.
The answer, Chuck eats the
answer
cupcake.
is I eat the cupcake. Why is there no new revolutionary paradigm in mathematics like calculus and algebra that is uncovered today as opposed to the last millennium when many fewer people were working on mathematical problems?
What's up with that?
You guys have done nothing.
I mean, there's definitely been a ton of development in math and new fields developed. Most of the math that exists. So, okay, algebraic geometry, there's this very interesting phenomenon that's been happening in the last century or so, but even the latter half of that. If someone tried to think of like a grand unified theory of math, something where you're trying to understand what are these weird connections that come up in seemingly very disparate parts, one of those fields that tends to take that perspective, kind of stepping back and saying, hey, what if prime numbers and like functions were really living in the same kind of world, and the facts that we know about one tell us facts about another? A lot of the people doing algebraic geometry, that kind of fits in there. You also have a pretty big revolution in the way that people think about math, where there is a thing that's called category theory, which is extremely hard to explain, and it's kind of like a language. It's sort of like a new language with which mathematicians think about their work that didn't exist 100 years ago. It's very much a different like way of thinking. And it's just quietly happening among these circles, not in a way that's very popularized. It's never going to show up in your high school calculus class, but it's absolutely like a new thing.
Okay, but you're saying it exists within math, but none that have shown up in our K through 12 textbook.
Nor should they. Like, I don't think you should shove category theory into a K through 12 textbook.
Yeah, I got to say, what Grant's doing right now is he's throwing shade at all those mathematicians back there that Akia is talking about. He's like, our stuff is so complex right now that, yeah, you can't even learn it, okay?
Okay.
Only 3 people can learn it in the whole world.
That's it, baby.
No, I know you're joking, but I hate when this is kind of how things come across as like, oh, this is so complex. It's more like, so you have certain people doing a certain job, like a research mathematician trying to find proofs. This is tools for that job. It's not a great tool for other jobs, like maybe writing programs and using mathematical modeling for the like simulation that you're running. Not as good a tool for that job. But for their job of writing proofs, it's like, here's this new tool. It's come into invention. Once you want to pursue that job, hey, we can make it as approachable as we want. But because I don't think everyone should do that job, like we shouldn't put it into K-12. And there's a ton of stuff that's too complex to describe that's vocational, right? If you want to understand like the exact way that injection molding works or something like that, it might be something that's inappropriate for a podcast, not because it's like highfalutin, super math brain. It's just because, hey, things that are very peculiar to one job tend to involve a lot of assumed jargon and a lot of assumed context from the people learning it. And it's just not meant to be.
Akia, guess what? It's there, but it's not necessary for you on a need-to-know basis. You're on a need-to-know basis, Akia. And there we go. All right. I've heard it said that mathematically we know properties, some or all, I'm not sure, of dimensions higher than what we observe. Could you please elaborate upon this? What can we say about these dimensions?
I think this is one of the big misconceptions when mathematicians talk about higher dimensions. People are like assume that they are talking about something that should be physically realized. But so ultimately, when you're doing math, sometimes you might have something that can be described by multiple numbers. You have some system like a little particle moving around, and you describe its like velocity with some list of numbers and its position with some list of numbers. And you often find it useful to take all your numbers and just list them together. And if you have a list of 3 numbers, you could think of it as a point in a 3-dimensional space. If you have a list of 2 numbers, you could think of it as a point in a 2-dimensional space.
Uniquely.
But
Yeah.
uniquely, yeah.
Yeah.
And mathematicians and physicists realize like, hey, sometimes we're solving a problem and we have a list of like 4 numbers or 5 numbers. It was really useful to be able to like visualize what was going on when it was a list of 3 numbers by having this unique association between a triplet of numbers and a point in a 3D space. They're like, why can't we do that? Why can't we say there's some abstract 4-dimensional space, not in like physical reality, but that's just going to represent whatever problem I'm solving, where there's a quadruplet of numbers that come up. Or in machine learning these days, right? When a large language model reads your text, the first thing it does is it turns a given word into a really big list of numbers, like tens of thousands of numbers. And it's very common for researchers to think of that as a point in an insanely high dimensional space and to use geometric ideas to describe what's happening to it through the model. But of course, we're not saying there's like a 12,000 dimensional space in physical reality. It's just that it's a nice way to describe lists of numbers.